I've seen this time and again, year after year. Hear that? A good solid thud when I tap this post. It's been holding up a section of our garden fence for near 20 years, and it's still sound, dry as a bone. Now, look at this one. I just push my thumb in, and it easily sinks into the soft, dark wood. See that? Just a few years in, and it's soft as an old sponge, rotting right through. This small difference, a few stones and an inch of air, is often what decides whether your outdoor wooden structures stand strong for years or turn to sawdust. This isn't just about saving a board. It's about saving the whole structure and the effort you put into it. It's a lesson passed down through generations, simple but profound, that can save you countless hours of repair and replacement down the line. Today, I'm going to show you how my grandfather taught us to simply elevate our wood to save our labor and make common outdoor structures last decades longer. The secret isn't fancy chemicals or expensive treated lumber. It's just breaking the wood's contact with the damp ground and letting the air do its work. We'll use nothing more than simple, non-absorbent spacers, like flat stones or brick scraps, to lift the wood just enough. This prevents moisture from wicking up into the timber, the main cause of rot. Many sheds, chicken coops, and raised beds fail early because of this one overlooked detail, costing time and good materials. I'll show you exactly how to do it, what materials work best, and even how to apply this to structures you might already have built. You'll learn the most important mistake folks make with this method, how to get started on your own project with confidence, and how to test to ensure it truly works for your situation. My earliest memories of seeing this trick go back to when I was just a boy, maybe 8 or 9 years old. That would have been around 1952. We had an old storage shed out near the barn where Pa kept some tools and feed sacks. Its sills were rotting away, and the whole thing was starting to lean. I remember my father, a strong, quiet man, and my grandfather working together. They used long iron bars to carefully lever up one corner of that shed. The wood underneath was black and soft, crumbling to the touch just like that fence post I showed you. My grandfather would then slip a flat, weathered fieldstone thick as my hand right under the sill. He would often say that the earth was always reaching for the wood, and you had to give it a good, dry breath of air. They did that all around, setting those sills onto stone and a little bit of lime mortar to keep them level. That shed stood for many more years, and the new sills never rotted at the ground line. It seemed like such a simple thing, but it made all the difference. Now folks have studied this, and it's well understood. Wood rot isn't just wood getting old. It's caused by tiny fungi eating away at the fibers. These fungi need a few things to grow: food, which is the wood itself, and warmth, oxygen, and most importantly, moisture. When wood sits directly on the ground, especially in places where the soil stays damp, it constantly wicks up water. This provides a steady supply of moisture for those fungi. Scientists call this capillary action, where water travels upwards through small pores in the soil and into the wood. Breaking that direct contact, even by an inch or two, stops that wicking and lets air circulate, drying the wood out. That's the core truth that Grandfather knew by instinct, a wisdom that time and observation have only confirmed. The mechanism of preventing rot through elevation is straightforward, almost elegant in its simplicity. When a piece of wood, like a shed sill or the base of a raised bed, sits directly on soil, it acts like a wick. The wood's natural fibers draw moisture up from the damp ground, keeping the lower sections perpetually wet. This creates an ideal breeding ground for decay fungi by inserting a non-absorbent material, a stone, a brick, a concrete paver, between the wood and the soil. We create what's called a capillary break. This break prevents the continuous wicking of moisture. Then, because the wood is no longer touching the ground, air can move freely underneath and around it. This constant airflow helps to dry any surface moisture from rain or dew, keeping the wood's moisture content too low for those rot fungi to thrive. Now, this method is best suited for structures where the main load is distributed over a wider area, not for point load foundations that bear the entire weight of a house. Think of common outdoor items, garden sheds, chicken coops, small utility buildings, raised garden beds, compost bins, fence posts that aren't structural, or even simple wood storage racks. It's especially useful in areas with heavy rain, poor drainage, or damp ground where conventional methods might still struggle. It won't be the right fit for major house foundations or large barns that need deep, engineered footings to meet specific building codes and carry immense weight. For materials, you'll want anything durable and non-absorbent. Field stones, flat pieces of slate, old bricks, or concrete pavers all work wonderfully. The key is that they shouldn't soak up water themselves. Some softer, porous stones like certain sandstones might still wick moisture, so avoid those. You want something dense that will hold its shape and not allow water to pass through easily. Scraps of pressure-treated lumber are sometimes used as a spacer, but that just moves the problem. The goal is to break the wood's contact with the dampness, not just use a more resistant wood against it. All right, let's get to the doing. Whether you're building new or working on an existing structure, the principles are the same, though the process differs a little. For new construction, first prepare your site. Level the ground where your structure will sit. You can dig down a few inches and fill with gravel for better drainage, or just rake it smooth and firm, ensuring good surface drainage away from your foundation. Next, mark the footprint of your structure. Use stakes and string to show where your sills or bottom framing members will rest. This guides accurate spacer placement. At each corner, and every 2 to 4 feet along the length of your sills, depending on structure weight and wood span, place your chosen non-absorbent spacers. If using field stones, pick flat ones with consistent thickness. For bricks or pavers, simply set them in place. Remember to wear sturdy gloves when handling rough stones or bricks to avoid cuts or scrapes. Leveling and stabilizing these spacers is crucial. Use a long level across them to ensure they are all at the same height. You might need to dig out a little soil under some, or add a thin layer of sand or gravel under others, tamping it down firmly. For extra stability, especially with irregular stones, you can use a small amount of lime mortar, or just tamp soil very firmly around them. The goal is a rock-solid level base. Once your spacers are level and stable, carefully place your wooden sills or frame directly on top. The wood should not touch the soil anywhere. Aim for a consistent air gap, ideally at least 1 inch. But even a ½ inch can make a big difference if air flows good underneath. Now, if you're working on an existing structure, this takes more care, but it's entirely doable. First, inspect the existing wood. If it's too far gone, crumbling, or entirely soft, replace those rotted sections before elevating. There's no sense in elevating wood that has already failed. Next, prepare for lifting. Clear away any obstructions around the base. If the structure is small and light, like a raised bed, you might lift one side with a strong helper or a lever. For heavier structures like sheds, you'll need a floor jack or sturdy levers and blocking. Never work alone when lifting heavy objects. Always use proper lifting techniques. Lift with your legs, not your back. When raising a structure, immediately place stable cribbing or solid blocks beneath it for support. Never rely solely on the jack or lever. Once lifted safely, begin elevating. Start at one corner. Carefully lift the structure just enough to slide your chosen spacer underneath the sill. Place it firmly, move to the next point, and repeat, working around the structure. The goal is to lift it consistently and gently. As you place each spacer, use shims, small pieces of durable, non-absorbent material, if needed, to ensure the structure remains level. Once all spacers are in place and the structure is resting on them, double-check for stability. Gently rock the structure to ensure it doesn't wobble. If it does, adjust your spacers or add more until it's perfectly solid. Finally, ensure the air gap you've created isn't filled by settling soil or garden debris. You might need to clear away soil slightly around the base to maintain that crucial airflow underneath. Remember, the goal is always to create that clear separation and allow for air circulation, letting the wood breathe. While this elevation method is powerfully effective, it has its limits and conditions, and it asks a bit of thoughtful attention from us. First, consider the kind of wood you're using. Even with elevation, some woods like redwood or cedar have natural rot resistance and will hold up longer than plain pine or fir. This method doesn't make weak wood indestructible, but it vastly improves the lifespan of any wood by removing a major cause of rot. If your local building codes, the rules for building in your township, specify pressure-treated lumber for ground contact, this elevation method may not fully replace that requirement for structural parts, especially for larger homes or big decks. Always check what your local codes say if you're building something substantial. The climate and how moist the air generally is also play a role. In very humid places, even with good elevation and consistent airflow, wood can still struggle if it never fully dries out between rains. Regular inspection is key in these areas. If you notice persistent dampness or any early signs of a dark, fuzzy growth appearing on the elevated wood, it might mean you need to improve the ventilation around the structure or even consider a light wood preservative applied to the lower sections. This isn't a fix it once and forget it solution for all time. It's a practice that benefits from ongoing observation. Good maintenance is crucial for this method to keep working as it should. Over time, soil can slowly build up around the base of your elevated structure, or leaves and garden debris might accumulate in the air gap. These things can, unfortunately, undo the benefit of elevation by holding moisture right against the wood, almost as if it were on the ground again. Periodically, maybe once a year, take a few minutes to clear away any soil, mulch, or plant growth that's creeping into that air gap. Also, make sure that any water from rain or washing drains away from the base, not towards it. If you do see signs of rot appearing despite the elevation, such as darkened soft wood that gives under pressure, it's a clear signal that the wood is still getting too much moisture. This is your cue to investigate if the airflow underneath is blocked by something, or if there's another hidden source of dampness from above, perhaps a leaky roof or splashing from a nearby downspout. Sometimes the problem isn't the ground, but water coming from somewhere else. Now, you can expect a much longer life for your structures, but not immortality. Depending on the kind of wood you use in your local weather, you could reasonably expect your structure to last twice as long, or even 3 to 5 times longer than if it were sitting directly on the ground. A shed that might rot out in just 5-7 years could easily stand strong for 20 or even 30 years, with proper elevation and steady maintenance. This method is about smart stewardship, making your labor and good materials go much further, not about achieving an impossible, everlasting result. It offers a practical, long-term solution by understanding and working with nature's processes, rather than trying to overpower them. To truly see the difference this method makes, you don't need fancy lab equipment. Just try this simple test yourself. Build 2 small, identical wooden boxes or frames, perhaps 12 inches square, from the same lumber. Place one directly on the soil in your garden, and the other elevate on a few stones, creating at least an inch of air gap underneath, just like I've shown you today. After a few years, maybe 3 or 5 seasons, go back and compare them. Push on the wood with your thumb. You'll likely find the ground contact box is soft and beginning to crumble, while the elevated one remains firm and solid to your touch. That tangible difference, that's the proof right there. Of course, soil conditions and amount of rainfall will vary, but the principle holds true in nearly every situation, wherever wood meets damp earth. This approach, this mindful separation of wood from damp earth, is more than just a practical building trick. It's a habit of caring for what we have, of working wisely with the natural world instead of constantly fighting against its ways. My grandfather and my father understood that a little extra effort and foresight at the outset saved a lot of grief, expense, and hard labor down the road. It teaches us to observe, to understand simple causes and their lasting effects, and to make the things we build last. It's about building wisely, with an eye towards lasting longevity, not just for quick convenience. What experiences have you had with outdoor wood and dealing with rot in your own structures? Have you found other simple, effective ways to extend the life of your projects or materials? Please share your wisdom and what you learned in the comments below. Your insights help us all learn and grow together. Next time, we'll talk about managing water around your garden in those dry summer months, so your plants stay happy and healthy even when the rain is scarce. Stay frugal, stay free.